right, so you need this page, the wave equations activity, as well as this wave equations flip-flap, because that's going to tell us the parts of the wave equation. This is going to tell us how to interpret them. Make sure you have these in your packet. This one is a flip-flap. So we're going to cut around the solid lines. We're going to leave that dotted line alone so it makes a flip-flap. This one is a template. So we're just cutting out around the outside. Very much like what we did yesterday. Okay? So. So we have our template cut out. And then we have our parts of the wave equation flip-flap cut out. Page 27 and 28 are our wave equation. I'm going to put the parts of the equation on this page. And then I'm going to put our wave equation template on page 28. I guess I made it just a little too big, so I'm going to shave some parts off of it. There we go. I'm going to put it on page 28. So it'll look like this. Yes, we are going to write in the boxes on our template. There's no cards to cut out. Weston, no, there's not social studies on Progress Book. There's not a discussion piece. B, you made it here, right? Yeah, okay. I just got your emails. Okay, so let's talk about the wave equation. We're going to talk about the wave equation here. Because what the wave equation is it's actually taking the parts of a wave that we already know. It's taking the parts of a wave that we already know and breaking them down for us. So this is that wavelength that we learned how to solve for. Okay, this is that crest to crest measurement. That one complete crest and one complete trough. Okay, that's just a Greek symbol used to represent wavelength. F, the variable F, is frequency, which of course is those wavelengths per second. Now v is equal to velocity. You will sometimes hear the word velocity interchanged with speed as if they mean the same thing. I want you to know that in fifth grade, we can go ahead and refer to them as the same thing, but I want you to know that they are different. Velocity and speed are not the same thing. So just constantly keep that in the back of your mind. Velocity and speed are not the same thing, but we will frequently hear them used interchangeably, especially in language arts. Language arts, creative writing tends to use scientific words slightly incorrectly, just like they use the word hypothesis and theory slightly incorrectly. Okay, now, wave equation. The wave equation is useful for electromagnetic waves only. All right, now the speed of light is 3 times 10 to the 8th meters per second. That is the speed of light. That is what all light travels at. Okay? The speed. Okay, so our velocity, we're going to come in here and we are going to define our velocity as those meters per second. Okay, so meters per second, that's measurement over time, like miles per hour. Meters per second, it is a fraction, it is a division problem. This is how fast the wave moves. We can also describe this as the oscillation rate, the rate of oscillation, like how fast it's vibrating. Okay? The reason it's important to know that this is the speed, the reason the speed of light is important, because if you know what the velocity is, if you know what the answer is, you can solve, you can figure out what one of these two parts is. Just like if I were to tell you that something plus 8 is equal to 12, you can solve for that something, right? Yeah, B, it's 4. Okay, so if I know that the speed of light is 3 times 10 to the 8th meters per second, and I know that the wavelength is 2, then I can solve for my frequency. I am not at all ever gonna make you solve those math problems because we are far, far, far apart. When we are in class together, yeah, I was gonna make you try that. I was also gonna give you calculators, so don't stare at me like I'm crazy, okay? Now, on your homeworks and on your reading passages, the last 2-ish problems for wave equation ask you to solve that. That's because I usually ask you to try those for funsies. But you're at home, I'm not gonna make you solve that kind of math problem, okay? So you don't have to solve those. All right, so, yes.
Can you show me the definitions for the upside down Y thing and the F?
We haven't done the upside down Y thing or the F yet, but velocity is there. So wavelength, we know what a wavelength is. What's a wavelength, Oak? What's the definition of a wavelength?
How dang it, I just forgot.
That's okay. All right, a wavelength is the length of one complete wave cycle, which we know is a complete crest and a complete trough. We know that a wave cycle is one complete crest and one complete trough. Okay, and then of course the frequency is what? What's frequency? What do you know frequency to be? Grace?
Frequency is the number of wave cycles in 1 second.
Correct. It's the number of wave cycles that can fit in a second. Okay. So it's the number of wave cycles in 1 second. Now we know that in science, it's a huge deal about writing things down. We collect data. That was the very first thing that we ever talked about in science, was collecting data. And so when we are collecting this data, we know that there are relationships. We can find out relationships. Math equations, the mathematics behind all of science, is what describes these relationships to us. Okay? So this idea of having an answer and having a variable to figure out something, this defines a relationship. So because we can use velocity, wavelength, and frequency in a math problem together, they have a relationship. They define each other. Okay? And we know that because we have a measurement and we have a time frame. All of these are related. Because I know that these things are related, I can define light waves based on these variables. Okay? Zayden, do you have a question? Okay. All right. Now, we're going to define the relationship of velocity, wavelength, and frequency. Okay?
Okay.
If you know the wavelength you can find frequency because velocity stays the same. The speed of light is the speed of light. It's the constant of the universe. It's 3 times 10 to the 8. Which means we're going to take that 3 and put 9 zeros at the end of it. That many meters in a second.
That's a lot.
Tyler. I know, it's a lot because it's very, very, very fast. It is the speed of the universe. Gavin, do you have a question?
Yes, I can't see the notes.
Why?
Like the top note.
The top.
Because okay, there.
There. Can you see it now?
It's because her network its bandwidth is low.
Skylar, did you have a question?
No.
Okay. Okay. So if these things are related, so if I know the wavelength, I can find frequency. What if I know the frequency? Emily?
If you know the frequency, you can find the wavelength.
Exactly. If you know the frequency, you can find the wavelength. It's something called transitive property. It's the idea that if I know that the answer is 12 and I know somebody gave me 8, I can figure out what I started with. At the end of the day, I had 12 apples. Mrs. Hayden gave me 8. How many did I start with at the beginning of the day? Blank plus 8 equals 12. 4. Okay? And that is the idea that almost all of your basic algebra is based off of. This is the kind of mathematics that you're going to get into in middle school, and the whole reason we learn it is because math defines scientific relationships. It defines this. This is defined by mathematics. So you have to be able to understand that to be able to understand how the world operates around you. So, when we are looking at a wave, okay, let's move to page 28. Let's look at these two different waves. Okay? Let's look at these two different waves. Let's start with the easiest to identify piece. Okay, so our answers are going to be either low or high, long or short, because we're not going to mathematically solve these. I'm not going to ask you to do that kind of math. Okay, so how would you describe the wavelength of wave number 1? Using descriptive terms, would you say it's long or short? Zayden, short. Wave number 1, you'd call this short compared to this one? Michaela? See a lot of people saying short.
I would say short.
Tyler T saying short. Michaela, what would you say?
Long.
Yeah, I would probably call it long too. So let's look here. Okay, let's say that these boxes are equal to a meter. Let's just think of it comparatively. This has one complete crest and one complete trough. How long is this? It's 1. But this one takes up 4. So which one's longer? This one or this one? Number 1 or number 2? Wave 1 or wave 2? Put it in the chat. Wave 1 or wave 2? Which one's the longer one? Okay, correct. Wave 1 is longer. It takes 4 of these boxes to achieve 1 wave cycle. 4 whole boxes to get this 1 wave cycle. Remember, it doesn't matter when we're talking about length, it doesn't matter how many wave cycles there are, it matters how long they are. So 1 complete crest and 1 complete trough is that long for wave 2. This is definitely shorter than that one. So when we come down here to wavelength, this one's long, and this one is short. Now, because we know wavelength and frequency have a relationship, because we know that the wave equation defines a relationship between these 2 properties, which one of these is going to have the most energy? There's actually a really easy way to remember this. We want to think, we're going to want to think, I see a lot of you thinking too, we want to think that the one that has the most wavelengths in the same amount of time is going to be the one that's high energy. And you are right. Number 1, this one is low. Long is low. Long is low. It's just slugging right along. It's just la 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 di da di da. It's low. It's just taking a stroll. So wave number 2 is going to have high energy. Long is low. It's just tiptoeing through the tulips, having a grand old time on its afternoon walk. Emily.
Can you show the whole page, like the whole
Yeah.
thing?
Yes. I think that's as good as I'm going to get. It's the whole page. Okay. Frequency. That's wavelengths in a second. Which one's going to have the lower frequency? The one that has the really long wavelength or the one that has the really short wavelength? Do you think we'll be able to fit more of the short ones in per second or more of the long ones in per second? Okay. Yeah, we're going to be able to fit more of these short ones in per second. So this one has a high frequency. Long is low. Long is low. That's kind of the key factor here with light waves. If there's a very long wavelength, it's got a low amount of energy, it's got a low frequency. Okay. Now, I want to reiterate, this is only possible because these are light waves. This is only something that you can count on in a light wave. We drew in our science notebooks, we drew those transverse waves because I told you we were going to start referring to and seeing light waves displayed as transverse waves. Transverse waves are mechanical waves. EM waves are EM waves. They're 2 different kinds of waves that look and act very similar. This equation, this idea is only useful for light waves, okay? Only electromagnetic waves. the oscillation of the electric and magnetic fields. Okay. Anybody have any questions?